Yeah, hello everyone. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Right. Yeah. Today we are going to discuss about the topic of fractions. Okay. Right. Simply, you know about the fractions, which is in the form of p by q, or nothing but fraction is nothing but a part of a whole thing, right? And you already aware of it. Types of fractions like proper fraction, improper, like fractions, unlike fractions, unit fraction, equivalent fractions, and so on. Okay, but in this class we are going to discuss about the topic of comparison of a fractions. So usually how we are comparing in a mathematics manner, we have to compare like which is the larger number and which is the smaller number. In such manner we are going to compare between the numbers, right? So generally in our regular life we can compare between the persons like their IQ levels, we can compare their heights, we can compare their weights, okay? But according to the numbers we are comparing between the numbers which is larger and which is smaller one. Am I right? So in the fractional numbers also, how to compare the fractional numbers, okay? But we are not going to follow the same regular method by converting the unlike fractions into like fractions by doing the LCM of denominators, right? Actually, we are having a like fractions, nothing but the denominators of the fractions are same, we can consider the fractions as like fractions. If the denominators of a fraction is different, we are consider the fractions as unlike fractions. To convert the unlike fractions into like fractions, what we are going to do? We are going to do LCM of the denominators. But here, to comparison between the two fractions, I am not going to take any LCM here. Okay, right. That means by using the cross multiplication method, we can compare between the fractional numbers. For example, if a number, the fractional numbers are in the form of a by b and c by d. If you take a by b and c by d, these two are two different unlike fractions. Let us consider these two are unlike fractions. To identification, to comparison between these two fractions, we are using the cross multiplication simply. What is that one? A into d and c into b or b into c. If the cross multiplication, nothing but the product of a and d is greater than b and c, then easily we have to say that a by b value is greater than c by d. Let us take one example. For example, I am taking like 2 by 3 and 3 by 4. 2 by 3 and 1 by 5. Let me take 1 by 5, okay? Yeah. 2 by 3 and 1 by 5. According to the cross multiplication, 2 into 5, 2 into 5 and 1 into 3 or 3 into 1. So 2 5s are 10 and 3 1s are 3. So which is greater? 10 is the greater number or 3 is the greater number? Obviously 10. So we can say that 2 by 3 is greater than 1 by 5. 2 by 3 is greater than 1 by 5. Just we applied the cross multiplication method. Okay. So to compare between the three numbers, there is a chance of first number is greater than the second number, first number is equals to the second number, and first one is lesser than to the second number. There are three situations comparison between the two numbers. Am I right? Yeah. Let me take the second one. If a by d, see this one, a cross d value is lesser than, first situation we have already done, and second one, if a cross d value or a into d value is less than b into c, then we can say that a by b value is less than c by d. A by b value is lesser than c by d. Let me take the example like 2 by 3 and 3 by 4. Apply the cross multiplication. 2 4s are 8, and 3 3s are 9. So 8 is lesser than 9. So obviously 2 by 3 is lesser than 3 by 4. Is it true? Let us check by the regular method, that is nothing but by taking the LCM of denominators. I am taking here 3 and 4. LCM of 3 and 4, which is nothing but 12. Now how we are converting into like terms? That means this denominator 3 should becomes 12. So 3 table 12 how many times? 4 times. So 4 by 4, and the second fraction is 3 by 4, and this 4, the denominator 4 should become 12. So we need to multiply with 3 because 4 table in 12 3 times. Then check here, 2 4s are 8, 8 by 12, and this is 9 by 12. See, we got the numerator values only here, 8 and 9. Because we can neglect the denominators. Once the fractions become the like fractions, we are just comparing the numerators. If the numerators, both numerators, the first one is greater than the second one, obviously first fractional number is greater than the second fractional number. Clear? Right. So let me check the third situation. The third situation is A into D is equals to B into C. So if the both of the numbers, that means when you apply the cross multiplication, A into D and B into C values both are equal, we have to recognize that both the fractional numbers are equivalent fractions. Both the fractional numbers are equivalent fractions. Let us see that one. For example, I am taking like 5 by 6 and 10 by 12. 5 by 6 and 10 by 12. Apply the cross multiplication. 5 12s are 60 and this one also 6 10s are 60. That means both are equal. So which is nothing but first fraction and second fraction both are equivalent fractions. So just by doing the cross multiplication, we can identify the which fractional number is greater and which fractional number is smaller. Clear? Now the next concept is how we are going to find out the LCM of fractional numbers. So until then you have learned about that LCM of whole numbers or integers. So LCM of whole numbers, okay, or LCM of natural numbers we have discussed. But what about the LCM of fractional numbers? For example, if you take the numbers like 2 by 3 and 8 by 12, 2 by 3, 8 by 12, these two are fractional numbers. That too, these two are unlike fractions. In this situation, how to find out the LCM of these two numbers? So simply LCM of fractional numbers are nothing but LCM of fractional numbers is nothing but LCM of numerators. LCM of numerators by HC of denominators. So this is the formula to find out the LCM of fractional numbers. So for example, so 2 by 3 and 8 by 12. LCM of numerators. What are the numerators here? 2 and 8. What are the numerators here? 2 and 8. So what is the LCM of 2 and 8? 2 and 8 LCM is 8 only. Check. So 2 1s are 2, 2 4s. 2 4s are 8. But 1 and 4 there is no common factor, so directly you can multiply. So 2 1s are 2, 2 into 4 8. So LCM of numerators is 8. So according to the formula, LCM of numerators is 8 and HCF of denominators. Denominators HCF. 3 and 12 HCF. 3 and 12 HCF. We know that 3 and 12 we can do by continued division method. So 3 table, 3 4s are 12. So whenever we get the remainder 0, its divisor is HCF. Am I right? Whenever we get the remainder 0, then we have to consider its divisor is HCF. Or else we have to continue the division like that. Okay, what is the HCF we got? 3. Therefore, LCM of 2 by 3 and 8 by 12 is nothing but 8 by 3. This is the LCM of fractional numbers. Got it, children? How we are finding the LCM of fractional numbers? Simply by using the formula LCM of numerators by HCF of denominators. LCM of numerators by HCF of denominators. Similarly, how to find the HCF of fractional numbers? HCF of fractional numbers. So HCF equals to same like that, similar formula. Can we get it? Can anyone got the formula? Yes, very good. HCF of numerators. HCF of numerators by LCM of denominators. So I am taking the same example, which is nothing but 2 by 3, example 2 by 3 and 8 by 12. Okay, I am taking the same example. Let us identify the HCF of numerators. So 2 and 8 HCF. 2 and 8 HCF. So 2 table, 2 4s are 8. So remainder is 0. Whenever we got the remainder, then its divisor is HCF. So HCF I got 2. And LCM of denominators. LCM of denominators. So denominators 3 and 12. So try to identify the LCM. So 3 table, 3 1s are, 3 4s are. There is no common factor between 1 and 4. So LCM is 3 into 1 into 4, nothing but 12. LCM is 12. So HCF of 2 by 3 and 3 by 12 is nothing but HCF of numerators we got 2 and LCM of denominators we got 12. So after cancellation 1 by 6. Both numerator and denominator can be cancelled in 2 table. So 2 1s are 2 6 are. Clear? So this is the way to find out the LCM and HCF of fractional numbers. Clear? Check once. What is the formula for LCM of fractional numbers? LCM of numerators by HCF of denominators. Similarly, HCF of fractional numbers is nothing but HCF of numerators by LCM of denominators. So today we have discussed 3 concepts: comparison between the fractional numbers and LCM of fractional numbers, HCF of fractional numbers. I hope you all enjoy this class today. So thank you one and all. Have a nice day. Bye bye.